Alright, so here we are. The second portion, this is going to be numbers 15 and 17, I believe, is what we have left. Yeah, 15 and 17. So going through here, one-tailed, two-tailed real quickly. The main thing is you read the last part of this particular question and it says, at this level of significance, can it be concluded that the average phone bill has increased? So what our interest is, are we looking at both sides or one side? In this case here, we're only caring about have we gotten greater. Doesn't the question isn't about whether or not we got less. So that makes us a one-tailed. Number 17, we come to this problem, same thing. I'm here at the bottom portion, and it says at this significance level, can it be concluded that the average is still the same? Okay, so still the same. So it doesn't talk about whether it's greater than or less than. It's just saying that it is this number or it is not this number. So we can see that in this case here, we established for number 17 that our mean would be that we are equal to 5.8. Our alternative hypothesis, our claim in this situation, sorry about that, our claim, I forgot to add that into the sheet. Our claim in this situation would be that we're not equal to 5.8. Now, because of the fact that we didn't talk about being less than or greater than, then this makes it a two-tailed test, because what we're concerned about is we go and look at our particular display, our normal curve laid out. What we see is that we find our critical values, which is 2.093 from table F. We place those on our curve. We find our t-value. Our t-value is negative 3.46, which falls out of that happy area. So you remember our happy area that we would say that there's not any change, that there's no grounds for change, that nothing has changed at all, would be right there in between those critical values. And so in this case, what we're essentially saying is we're saying, okay, so here we are, we've got our mean. Our mean was established at 5.8 doctor visits, right? We had a standard deviation of 2.52, so one standard deviation above, one standard deviation below, and so forth and so on. And we go through and we establish, well, at what point will we get to the situation where we would say, wait a second, there is a significant difference, and so there is enough to say there's a change. And that established point is this critical value that we found from table F. We find out that in this case here, we are negative 3.46. That's way outside of our critical value. We're outside of that happy area. So there is evidence to support the claim that the mean has changed. All right, so let's just go through real quickly now and kind of touch basis on when we support and when we don't support. All right, so give me one sec. Hit pause. Alright, so we've gone through, we looked at the one-tailed, two-tailed for each one. I made this into two videos, and I want to come back and just kind of go through each one real quickly and talk about when we reject, when we accept the claim that's going on here. So we go back to number 7, and we've already talked about number 17. We'll kind of bounce through and try to keep this clean and together. Alright, so our problem was here is that, we come across this problem and it has been stated that the average time on the cell phone is 2.27 minutes. That's my average. Oops, that's my average time. Okay. At the very end of this question, what we're trying to establish is, can it be concluded that the average is different from the population? That this sample is different? Is there enough evidence here to show that there's a difference going on? So my claim is to show that I'm not equal to the normal average. Alright, so in this case here, we saw there was enough evidence to support that claim that there was a difference. So we would, in this case, reject the null and keep, it's not that we accept the alternative hypothesis, it's just that there's enough information available to support this claim that we've made. Okay, let's go to the next one. So number 9. So we've established in here that the average height of the building is 700 feet. Okay, we did a sample. We found out that the sample was only 606.5. So in this case here, because we made a claim inside of this problem, we claim that the average building would be greater, then our alternative would be less than that. So when we found out that we were 606, we established some critical values, we found our t-value, we were able to reject the null hypothesis because we are outside of that area. So we are not going to accept, because we're not inside this happy area around the 700, we're outside that critical value. So we can say, nope, that is incorrect. We are not going to be greater than 700 because we obviously have shown from this sample that we are way less than 700. Number 13. So we go through the problem. They established previously at some point that $54.8 million was the average cost of making a movie. They collected a sample of 15 movies more recently, and they found out that the average of those 15 movies was $62 million. And at this point right here, what we see is we see that, okay, $62 million is this new average. So which one is our claim? So we read the bottom part and it says, can it be concluded that it costs more than average to produce an action movie? So what we're saying now is there a change going on? So our claim becomes the alternative. Alternative, and if you look at the answer key in the back of the book, it really just depends. We could say the mean is, a lot of people, instead of putting less than or equal to, it just really depends on who's the person guiding this. You could either be the mean is equal to 54.8, or you could say the mean is less than or equal to. In this case here, I mean, our point is this. Our mean is either going to be this, or it's going to be greater than that. And some people will direct and say that you want to cover both areas. So in this case, once again, we're outside that critical area. We're not in the happy area. So remember, our happy area is here. Whoops. We're outside of that happy area. So since we're outside of this happy area, then that means that our null hypothesis does not hold. So we reject that null hypothesis, and they say that there is evidence to support our claim. Okay, there is evidence to support that the average is greater than 54. All right, and one last time, number 15, excuse me. So number 15, we come across and cell phone average bill is $50, and we collected some data, and we found out that the new average of this sample was 56. And so at the significance level, we wanted to see if we could conclude that the average phone bill has increased. So, here's our happy spot. If we're inside this happy spot, then we would not reject the null. We would say there's not evidence to support this claim. Okay, our claim being that the bill has gone up. So we find out that our bill, the critical value is there. We're located right here. So we are outside of that happy area. So therefore, there is enough evidence to support our claim. We can reject the null hypothesis and support our claim. All right, so that's that kind of gives you a run through of one-tailed, two-tailed. It kind of gives you an idea of once you establish this, you look at it, what does it look like on the picture? Draw yourself the picture, establish where these values are, and then go from there to decide whether or not you can accept, or excuse me, whether there's enough evidence to support your claim, or whether you should reject the null hypothesis. Okay, so let me know if you have any questions. This is a tricky section. It's the wording, it's the language. It takes time and practice. You might want to work these several times. Cover up the answer key. And keep coming back to it and see if that helps.